Let's talk about AI. Today, we're going to demystify it. We're going to start with these huge, kind of mind bending ideas and then zoom all the way down to the one surprisingly simple building block that makes it all work. So, here's our game plan. First, we'll get the big picture of AI. Then, we'll look at the three main ways it learns. After that, we're going to peek inside the digital brain itself. And finally, we'll zero in on the simple job of a single neuron before putting it all together. Let's dive in.
Okay, first up, the AI big picture. I mean, what are we really talking about when we say AI? Let's start with a really simple real-world task to get us grounded. At its very core, AI is about teaching a computer a skill. Imagine trying to get a machine to do something very human, like just looking at a photo and deciding if the face is male or female. The goal here isn't just to follow a bunch of rigid instructions, it's to learn a pattern. But how on earth does a machine learn something so, nuanced?
Well, that question leads us perfectly into our next section. It turns out there isn't just one way to teach a machine. There are a few different key strategies.
So you've got these three main ways AI learns: supervised, unsupervised, and reinforcement learning. They're all super interesting, but for our purposes today, we're really just going to focus on the first two. They give you the perfect foundation for understanding the basics. So here's the key difference. Think of supervised learning like studying for a test with flashcards that already have the answers on the back. You feed the AI thousands of photos that are already labeled male or female, and it learns the patterns from those labeled examples. Unsupervised learning, on the other hand, is like giving it that same giant pile of photos, but with no labels at all. You just tell it, here, sort these. The AI has to find the hidden patterns all by itself.
Okay, so we know how it can learn, but where does all this learning actually take place? Well, the answer is pretty cool. It happens inside a structure that's modeled on the most powerful computer we know of, our own brain.
Yeah, whenever you hear people talk about modern AI, 9 times out of 10, what they're really talking about is a neural network. You can basically just think of it as a digital brain. It's a huge web of these tiny interconnected processors, or neurons, that all work together to solve a problem. And that, right there, is the million-dollar question. If this whole amazing network is just made up of tiny, simple little parts, how does it produce such intelligent-seeming results? I mean, how do you get from a single digital switch to something that can actually recognize a human face?
You might be surprised to hear that the answer isn't some mystical, complicated secret. It's actually incredibly simple. It all comes down to some very basic, very elegant math.
This right here is the atom of the AI universe. It's the fundamental building block. The technical name is a perceptron, but that's just a fancy word for the simplest possible kind of artificial neuron. Its job is surprisingly straightforward. It just takes in a few pieces of information, weighs them, and spits out a single answer.
This is it. Seriously, this little formula is the entire thinking process of a single neuron. It takes every piece of information coming in, that's an input, and multiplies it by a number that represents how important it is. We call that importance factor a weight. That's the whole job. So let's go back to our face example. An input might be a measurement, like the spacing between the eyes or the width of the nose. The network learns over time which features are more helpful. So in this case, maybe it's learned that eye spacing is a little more important for its decision, so it gives it a slightly higher weight than nose width.
So the neuron just does its simple little job. It multiplies the input value by its weight, adds them all up, so that's zero point 0.4 times zero point 0.4 plus zero point 0.9 times zero point 0.2, and it gets a final output of just 0.32. That single number is the only thing this neuron contributes. It's the only information it passes on to the rest of the network. Okay, so we've got this one tiny neuron doing one simple piece of math. Now, let's zoom back out and see how we get from that tiny calculation all the way back to our complex face-recognizing AI. And this is the magic of AI. A single neuron is simple. You could even say it's kind of dumb. It can only do that one little calculation. But when you connect millions of them together into a huge network, something incredible happens. They can collectively learn to do these incredibly complex tasks. So this process of learning is really just the network running through thousands of photos, making a guess, checking if it got it right, and then slightly adjusting all those little weights to make a better guess next time. It's a massive, system-wide process of trial and error. And the cool part is, we can actually measure how well it's learning. We measure this with something called an error rate. For example, when it's just starting out, a network might be wrong about 5.1% of the time.
And to be specific, this is a top 5 error rate, which means the right answer wasn't even in its top 5 guesses. So, not a great start. But hey, it's learning. But after seeing thousands, maybe millions more examples where each one is a tiny lesson, a minuscule adjustment to those weights, that error rate starts to fall. It drops to 3.57%. This falling number is the proof. It's the concrete evidence that the system is moving beyond just simple calculation. It is genuinely learning.
So if there's one big idea to take away from this, is that mind-boggling complexity can emerge from millions of very simple rules working together. A neuron just does multiplication and addition, but a network of them can learn to see, which really leaves us with one fascinating final thought. What else can it learn? And where does this all go from here?